Hi everyone, this is a GRE Quantitative Comparison practice question. This QZ question is basically from the topic ratio proportion. Though the question is worded as a ratio proportion question, the concept that we'll need to solve this question is primarily about some properties of how fractions behave when they are improper fractions and when they are proper fractions, right? Let's learn this as we solve this question. Let's get started with the question. But before that, just wanted to check out, have you subscribed to our channel? If so, thank you. If you have not subscribed, please subscribe to the channel and turn on notification so that you will get notified every time we upload a question video or a Gyan video about GRE. This question basically says, this is a question stem. The ratio of men to women in a club is 5:3. An equal number of men and women joined the club and no one left the club. Right? This is the information that we have. Men to women membership right now is 5:3. An equal number of men and women, say 10 men joined, 10 women joined, 50 men joined, 50 women joined, no one left the club. Now what is asked to be compared? Quantity A is new ratio of men to women in the club. We do not know how many of them joined, but equal number joined is what we have. Ratio of men to women in the club and the quantity 5:3, which is the original ratio. We need to compare these two and check out which of these two ratios is a larger value. The four answer options you are familiar by now. Quantity A is greater is choice A, quantity B is greater is choice B. The two quantities are equal is choice C, and if you can't compare, right, you don't have data to compare, cannot be determined is basically choice D. Let's get started. Let's start with the first one because the second one is just a ratio, so it's easy. There's nothing really to work there. This is a place where some work is required. The ratio of men to women in a club is 5:3. So essentially, men by women, if you look at it, this ratio represented as a fraction would be 5/3. You can say it is 5x men, 3x women. Good, no problem at all there. Now what they're saying is an equal number of men and women joined the club and no one left the club. So the number of people, if it is 5x initially and 3x initially, let's say k men joined and k women joined. We need to compare 5/3, which is the new quantity B, which is the original ratio, with this 5x plus k by 3x plus k. Few things to note. 5:3, the ratio of men to women, because you're talking about number of men and number of women, this has to be an integer, will have to be a positive integer. So 5x and 3x together will be positive integers. Men and women equal number joined, so this is to be a positive quantity, has to be an integer. So k is a positive integer. Now, before we set about actually working on this quantity, I want to walk you through two types of fractions. A fraction of this kind is called a proper fraction. A proper fraction is one in which the magnitude of the fraction is less than 1. Right? 3/5 is 0.6. This is less than 1. An improper fraction is 1. We'll do it in the next slide. An improper fraction is something like a 5/3 whose value is equal to 1.666. A fraction whose value is greater than 1, whose magnitude is greater than 1, is called an improper fraction. Now, let's look at what happens to a proper fraction and what happens to an improper fraction when you add a constant k, which is a positive number, to it. Start with a proper fraction. 3/5, the value is 0.6. Let's say we'll add a very small quantity. Let's add a 1 to it. If I add a 1 to it, 3 plus 1 will become 4. I'm adding the same 1 to the denominator. 5 plus 1 will become 6. The value of this fraction is equal to a 2/3 when you reduce it to a least possible value. 2/3 is equal to 0.66. We'll do this step once more. We'll add one more to this, right? 4 to a 2 you added 1, or to 4 you add a 1, whichever one. We'll add it to this. So this becomes 3. 2 plus 1 is 3. 3 plus 1 is a 4. The value is 0.75. So 3/5, you added a 1 to both the numerator and denominator. The value from 0.6 became 0.66. Now this 2/3, you added a 1 to the numerator and 1 to the denominator. The same positive quantity is added to both the numerator and denominator. The value of the fraction increases further. So if I have a proper fraction, p/q, where p is less than q, p plus k, where k is a positive number, q plus k, right? So let's check out whether the same behavior is exhibited when we are talking about an improper fraction. Let's start with what we have. 5/3, we know the value is 1.66. Let's add a 1 to both the numerator and denominator. So this becomes a 6/4. 6/4 is equal to a 3/2. This is a 1.5. We'll do one more step. Let's add one more to this, both the numerator and denominator of 3 and 2. So this will make it a 4 and a 3. The value is a 1.33. Here you realize that the value increases 0.6, 0.66, 0.75. Here you realize 1.66, when I added the same case, same 1 to both the numerator and denominator, became 1.5. Now I add a 1 to both the numerator and denominator of this fraction 3 upon 2, right? 3 plus 1, 2 plus 1. The value further decreased. Add 1 more to this, 5 by 4 will be 1.25, so on and so forth. Here you'll realize that the value keeps decreasing. So if it's an improper fraction, p by q, where p is greater than q, here p was less than q, here p is greater than q. Now if I add a k, which is a positive number, p plus k and a q plus k, right? So p by q will be greater than p plus k by q plus k, provided k is positive. Here we realize that it was lesser, in this case it is greater. What is the original ratio given to us? We have 5x, 3x, men and women. Equal number of men and women join the club. No one leaves the club. So 5x is a positive number, 3x is a positive number, the x is a constant which is multiplied to both. So obviously 5x is going to be greater than 3x. So we are talking about the case of an improper fraction. 5x upon 3x is an improper fraction. To that, if I add a positive number k, the value of the fraction has to decrease. So 5x plus k by 3x plus k will be less than 5 by 3. So this is your quantity A, this is our quantity B. So this number is going to be lesser than 5 by 3. This value is going to be a value which is lesser than 5 by 3. Quickly run through the comparison. This 5 by 3, we know the value is equal to 1.66. Comparison. Quantity A is a number which is less than 1.66. This is a number which is equal to 1.66. So quantity B is greater than quantity A. We don't even need to know how many people joined. As long as we know the number of people joined is a positive number, that is enough. And the original fraction is an improper fraction. We'll be able to do the comparison. Quantity B is greater than quantity A. Choice B is the correct answer to this question.